my name is Keith Dunn. I'm a senior of computer engineering, and our project is the PocketBeagle for robotics education. It modifies the TI RSLK Max to work with a single board computer called a PocketBeagle. The original TI RSLK Max comes with what's called an MSP 432 microcontroller, which is this guy right here. It's a great microcontroller, can do a lot of stuff, but by introducing the PocketBeagle to the system, we're able to have an actual Linux kernel operating on it, which gives us a real-time operating system. So you're able to actually program it in Python, as well as a number of other languages. And you can actually connect it through Wi-Fi, you can program it wirelessly, and you can actually run more complex programs on it as well. One of the issues in computer engineering courses that we currently have is that a lot of the systems that we use are pretty straightforward microcontrollers. We don't get a lot of opportunities to work with embedded Linux systems, and also we don't get a lot of opportunities to program in Python and other languages other than C and possibly C++. So what this system does is it actually brings a lot of those together in a robotics system and makes it very accessible for college students and college professors to access these new materials. So to implement the design on our project, we actually created a custom printed circuit board, which you can see in green on here, in which the PocketBeagle itself plugs in. It's this little black rectangle right there. So it acts as more of an adapter board for an existing unit that TI already sells as a full unit. So by using the printed circuit board, you can simply adapt it for use with the PocketBeagle. It's still completely functional with the original MSP 432, which gives instructors and students the option to switch out as needs change. I'd say the biggest challenge we had with this project was probably incorporating some of the more timing-sensitive systems into a Linux operating system. With the MSP 432, it only does what you tell it to do, so timing is not usually an issue with running more complex systems, but with a Linux operating system, there's a number of system interrupts happening at the same time, so it has to be much more timing invariant. So getting that to work with some of the subsystems that we're using on the TI RSLK Max was a bit of a challenge, but we were able to do it.